Hello guys, in this video I'm going over transpose of a matrix, like how to find a transpose of a matrix, and we'll go over some properties of transpose of a matrix too. Okay, so the first thing is the definition of a transpose of a matrix. Let's say we have a matrix Aij is m by n metric. That means I goes from 1 to m and j go from 1 to n. And if you are writing the transpose of a matrix A, it can be written as A to the T or A to the dash, can be written as A dash 2 sometimes, is equal to AJI, and it's going to be a n by m matrix. So basically what we're gonna do, we're gonna change the rows of matrix A to its columns and the columns to its rows, and then we can write the transpose. Let's do one example. Let's say we have a matrix A is equal to, I'm gonna write it down over here. Let's say 1 2 3 4 and then 5 6 7 8 9 10 11 12. Let's say these are the elements of matrix A, and we're gonna write the transpose of this matrix, and can be written as A. I'm gonna write T over here that represent transpose. So what we're gonna do, we're gonna write the rows of this matrix as columns of this matrix. That means the row of matrix, first row of matrix A is 1 2 3 and 4, so that'll be the first column of transpose matrix, so which will be written as 1 2 3 goes over here and 4 goes over here, and the second row is 5 6 7 8, and that will change to the column of this one, so that will be 5 6 7 8, and third row is 9 10 11 and 12, can be written as column of this matrix 11 and 12. So this is basically the transpose of matrix A. It's very easy, it's fun to work with. You just change the columns to the rows and rows to the columns. Anyway, it will work both ways. Okay, and let's talk about some properties of transpose. So first property, I'll say, I'm gonna write one over here. If you have a matrix, a transpose matrix, and if you do the transpose of a transpose matrix, you will get your original matrix back. You'll get A back. Okay, and we can use it over here. Let's see if that works or not. So you got A T, and we're gonna find the transpose of this matrix. So that means it will give me, so what I'm gonna do, the row of this matrix is column of this one, so can be written as 1 5 9, and then this one 2 6 10, and then third row becomes the column of this one 3 7 11, and the last one 4 8 and 12, and you see we got our real matrix, the original matrix back. So that means if you find a transpose of a transpose matrix, you will get your original matrix back. The second property of transpose is for any two matrices, let's say A and B of a same order. Let me write it down over here. I'm gonna use different color. So let me write it down. So let's say we got A and B, and we find the transpose of that. So this is basically equal to transpose of matrix A plus transpose of matrix B. Really useful properties That'll be helpful when you're solving problems. Okay, and the third one is going to be, let me see. Okay, so if A is a matrix and we got n a scalar, then it can be written as, let's say, n multiplied by matrix A. We did the transpose, so it can be written as, the scalar can be written out, and A to the T, so it does not affect the scalar over here. Okay, the fourth property is, it says if A and B are two matrices such that their product is defined, then let's say A and B and their product is defined, so we can find the product A and B. That means the number of columns of this one matrix A is equal to the number of rows of B. That means their product is defined, and we find the product and we did their transpose. Okay, the transpose of product of those two matrices is going to be equal to the transpose of matrix B into the transpose of matrix A. Again, really useful. You can use these properties of matrix transpose to solve the problems. Another thing we can learn from here is symmetric and skew symmetric matrices. So let's say symmetric matrix. Okay, so symmetric matrices. Okay, so symmetric matrices are if the transpose of a matrix is equal to the original matrix. So we have a matrix A and we find the transpose of A, and if both are equal, then we call those matrices as symmetric matrices. For example, let me write down 1 over here. So let's say I got 1, -1, 5, I got -1, 5, I got 2 over here, I got 1 over here, 1 over here, and 3 over here. Okay, and this is, let's say, A, and if I find A transpose, write a little smaller. If I find the A transpose, so basically the column of this is going to be row of that, or row of this is going to be column. It works both ways. So let's write down the rows of this one to the columns of this one. So can be written as 1, -1, and 5, then -1, 2, and 1, -1, 2, and 1, 5, 1, and 3. So 5, 1, and 3. And you see, both are same. A and A transpose both are same. So these kind of matrices, we call them symmetric matrices. So let's do the second one, which is called skew symmetric. Okay, skew symmetric matrices. Skew symmetric matrices. So skew symmetric matrices are if you have a matrix and you find the transpose and it is equal to negative of the original matrix A. So if you see a matrix that gives you this kind of result, like you have a matrix, you find the transpose, and they're both equal with a negative sign, then we call those matrices as skew symmetric matrices. Let me do one example of that. Let's say you got A is equal to, write it down over here, you got 0, 1, -1, -1, 0, 1, then you got 1, -1, and 0. Okay, so now if I find a transpose, which is going to be so the row of this is going to be column of this one, so 0, 1, -1, so 0, 1, and -1, -1, 0, and 1, -1, 0, and 1, 1, -1, and 0, 1, -1, and 0. Now if you see, look at this, so A transpose is almost looks like A but with the negative sign. Okay, so if I take a negative out from here, let's say if I put negative out, that means this becomes positive, this becomes negative, this becomes negative, this becomes positive, this becomes positive, and this becomes negative. Now you look at this, so this is equal to A, 0, +1, -1, 0, +1, -1, -1, 0, +1. So A transpose is basically is equal to -A. So these kind of matrices called skew symmetric matrices. Okay, now we're gonna do some problems on transpose of matrix. So one example we got over here is if we have a matrix and we have another matrix B, and we have to show that a product of AB, and then we're going to take a transpose is equal to B transpose into A transpose. Okay, so let's do it. So first of all, let's find product of A and B. So I'm going to write AB, which is equal to, we got 3, 4, 4, 5, and multiplied by B, which is 5, 3, 2, and 1. So we're going to use the multiplication property. The columns of first one, which is 2, need to be equal to rows of the second one, which is 2. That means we can multiply these two, and that gives me 3 times 5 is 15, plus 4 times 2 is 8, and 3 times 3 is 9, and 4 times 1 is 4. Then we got 20 plus 10 and 12 plus 5. That gives me 15 plus 8 is 23. Then we got 13, got 30 over here, and we got 17 over here. So this is A into B, but we need to find the transpose of A into B, so which is going to be AB and the transpose of AB. So change the rows to the columns, so it can be written as 23, 13, 30, and 17. So this is AB transpose. So let's do the right hand side, which is B transpose and A transpose, and then we're going to multiply them. So we know B is 5, 3, 2, and 1, so change the row to the column. So B transpose is, so this becomes this, so 5 and 3, and then we got 2 and 1, and then find the transpose of A, which is 3, 4, can be written as 3, 4, and 4, and 5. Oh, looks like A, so that tells me this matrix is a symmetric matrix because the transpose is equal to the original matrix. So 3, 4, 4, 5, 3, 4, 4, 5. So it's a symmetric matrix. Let's find the product of B transpose to A transpose. So going to be 5, 2, and we got 3, 1, into 3, 4, 4 and 5, multiplication rule. So this gives me 15. 2 times 4 plus 8. 5 times 4 is 20. 2 times 5 is 10. And here 3 times 3 is 9. 1 plus 4 is 4. 3 times 4 is 12. And 1 times 5 is 5. This is equal to 15 plus 8, 23. 20 plus 10 is 30. Sorry, what I wrote. 20 plus 10 is 30. And 13 and 17. So if we look at both the answers, AB transpose is equal to B transpose into E transpose. So both gives us the same matrix. Okay, so basically we proved it what they were asking us. Alright, thanks for watching the video, guys. Please share with your friends and subscribe to the channel, and I'll post more videos on matrices, like finding inverse or rank of a matrix in my upcoming videos. Thank you.